Good morning, lovely 12s. Right, buddies, here we go. We finally get a chance to do the very coolest topic of the whole of trig, and that's actually solving with the trig equations, which is really neat. You are going to get a chance to use some of your identities today, but we're going to go a bit harder in the next two lessons following this one. Today is just kind of the introduction level to it. Cool. Right then, so basically, you know how to do this a little bit from year 11, and you'll know how to do it using graphs. Okie doke. Even if, say, I'm the one who taught you in year 11, I would have taught you it with graphs, because it kind of lends itself well to understanding how the trig graphs relate to the answers. But you know how I've just fallen in love with cast, and so have you, my lovelies. In the last few lessons, you've become cast legends, Sex and the City as well, to solve with. Well, actually, I think, and people disagree with me on this, even in the maths department, I think cast is the be-all and the end-all, my lovelies. I think that the cast is the way forward no matter what. So here's what I'm going to do. I'm going to do a couple questions with you. I'm going to use my cast method to get you on board with me, but I'm also going to give the alternate of the graph method, so because you can solve with it as well, and so I'm not sure. You can decide what your preference is, and you can solve that way forevermore. Cool. Right then, buddy. So here we go. Our first question together is this. It says, find the solutions of the equation sine of theta equals a half in the interval where theta is between 0 and 360. Now, this is the key part, my buddies. Because the interval is between 0 and 360, we're going to expect multiple answers here, which is why you can't just push shift sine equals a half into your calculator, okay? So putting it in the calculator isn't going to get you any marks when these questions will be worth 4 or 5 or 6 marks. Cool beans? Right. So let's do it. Sine of theta equals a half. Okay, we're going to go with my method first, and here's my method. It's the cast method. So first step, if you're following along with me, is this. Start by drawing, oh, and everybody has to as well. I'm going to make you guys initially do it my way with me, so your notes will have both ways, but then I'll give you the option after today. Cool. So cast method's this. Start by drawing just a little axis. It doesn't have to be enormous, but it shouldn't be tiny either. Label it Sex and the City. And then you look at your question really carefully. And you say that it's sine of theta equals a half. Now that half is positive, yeah? That answer to sine of an angle is positive. Well, where is sine positive? Well, here and here. So what are we going to do? Well, we're going to draw stakes into those quadrants. So draw a big line up there, and then we're going to drop it down to the horizontal, and draw a line into this one as well, and also drop it down to the horizontal. Cool beans? That's step one. Step two is this, buddies. In your calculator, whether it was minus or whether it was positive, you're going to go sine minus 1 of a half. So even if it said negative a half, we would have still put a positive in. So no matter what we do in this stage, we always put a positive number in, because if you put that positive number in, what it tells you is it gives you an acute angle, because since all of them are positive in A, that means that we're going to get an acute angle if we put a positive in, which is what we want, a small angle. So here we go. Shift sine of 0.5 equals 30 degrees. So we've got 30 degrees there. Here's what that means, buddies. It means that this is 30, and it means that this is 30. Which means, buddies, we're ready to go in for the kill, for the final answer. So you ready? Here we go. So, theta equals, and here's the first one, 30 degrees, because you hit it there first of all, 30 degrees, starting at the positive x-axis, going anti-clockwise around, 30 degrees, but also all the way to there. How many degrees would that be? Well, if you said 150 degrees, you're absolutely right, and that's it. Answer of the full question. Sorry, 150 degrees, because it's 180 to go like halfway across all the way to there, and it's 30 fewer than that, so that's why it is 150. Now, if you tested those in your calculator, if you said sine of 150, it would indeed equal a half, as would sine of 30. Cool. And that's why I think my method is sweet. Do you see how that could have been a really hard topic? That would have been the hardest topic in GCSE, but we've made it just kind of simple and easy with cast. Okay. Here's the alternate. So this is my method, okay? This is cast, which I love. Cast. Okay. Now, here's the alternate, okay? This is what you'll have seen before. This is what you'll have seen before at year 11. Okay, starts off the same. Sine of theta equals a half. Okie doke, buddies. Now, with this one, you have to actually draw the actual graph of sine of theta, okay, between the interval of 0 and 360. It's still easy, buddies, because sine of theta is going to be like this. Cool, and it's just a sketch, so you don't have to be like amazing at it or anything. Cool, that's step 2 in it. Now, what you're going to do here, here's where it's a bit different, is we're going to label on about where we think a half is, so about there, let's say, and you're going to make it a continuous line all the way across like this. I wish I had done it in solid, so I'm going to rewrite it in solid. Oh no, I have to undo every single one. So here we go. So a nice solid line along like that, okay? Now, here's what you have to also know. That's 0, 0, 90, 180, 270, 360. Okay. Now, here's how you do it with the graphs, buddies. You look for the points of intersection, which are here and here. Okay, so we're treating it a bit like a simultaneous equation when we do graphs, which is very clever and it's very useful. It's a good method, I'm not going to lie, it is a good method, but it's no cast, by golly. And then once you've got that done, you're going to do the same thing, but we're not going to worry. But if it was minus, you'd just put minus in. So here's what you're going to do. You're going to sine minus 1 of a half and see what you get. Well, we know already that that's 30. Here's what you do then. You try to locate the 30 on your graph. So it's going to be the first one, right? Because it's less than 90, and this one's between 90 and 180. So it's definitely 30, so this is 30. Now, here is how your graph method works, buddies. This part here then, because of symmetry, that distance there is going to be equal to that distance there. So not in terms of the angle itself, but in terms of distance, this is 30 from here to here, and this is 30 from here to here, which means that the other angle, this one here, this purple angle here, let's get the purple out again, this purple angle here then, well, it's going to be 180 because that's all the way to where it collapses. Take away the 30 from symmetry, which equals 150. Which means we still get the same two answers. We still get then that theta is 30 degrees, and even 150 degrees. Bish bash bosh, there it is with the graph method. Now, I'll leave it to you to which one you think is the easier. I certainly, again, I'm going to say it for like the millionth time, but all the maths teachers disagree with me as well, but I honestly think that cast is amazing. I would use it if it was just me doing it. But yeah, you've got your graph method too, so whatever you prefer is cool. Right, here we go, a little bit harder. Solving the interval 0 to 360, 5 sine x equals minus 2. Okay, only difference here, we're going to get an ugly angle, and the quadrants are different for cast. So if you want, if you feel confident already, pause and get ahead of me, go. And if you don't feel confident, or you want to just see it or work with me, let's do it together. Okay, this will be the last time I do it in both methods, I think. So let's go cast first. And here we go. First things first is I don't like the way it's written, so I'm going to rewrite it having divided both sides by 5. I'm going to have sine of x is equal to minus 2/5. Okie doke. Cast method's next step is this then. Get your little picture down because this is the only drawy part of it. Sex and the city. Okay. Now sine here, sine of x is equal to negative 2/5. So our answer is negative. Now here and here is where sine are positive, is where sine is positive. That's where it's positive, and that's where it's positive, which means it's not going to be there. It's going to be here and here, where the sign is negative. Draw your sticks into both quadrants. So dash, 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 dash. Dash, 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 dash. Now, here's the cool part about this. If you're doing my method, this is where it just is nice and easy now. You're going to go sine minus 1, and you see how it was minus 2/5? Yeah, just bin that off. Just put regular 2/5 in. I'll show you why as well, I guess. But yeah, if you just put regular 2/5 in to begin with, I'll show you what goes on. Shift sine of 2/5 equals 23.6. 23.6 degrees. Now, if you put minus 2/5 in, like the question had, it would have been minus 23.7, or 23.6. So essentially, if you put the minus in, it would give you an angle that's orientated that way, which is fine, but it's just more to think about. So what I would say is just do a positive angle, because as soon as you got the positive angle of 23.6, it means that this is 23.6, and the direction doesn't matter, and this is 23.6. Well, and here you go, buddies, ready to go in for the kill, the final answer then. So here's your two angles then. So theta, first of all, could equal this. Well, starting at the positive x-axis, it would go to that stick there. It's more than 180. It's 23.6 more than 180, which means the first angle is 103.6 degrees, because it was 180 plus 23.6. The second angle goes all the way around to there, which is 23.6 less than 360. 360 take 23.6 equals 336.4, and that's the answers. Final answer, boom. Cool beans, buddies. That is my preferred method. Okay, final time I'm going to big it up, and final time I'm going to try to confirm for you if you like the graphs method, because you're quite good at this from year 11 and you want to keep going with the graphs. They are perfectly acceptable. So let's just check that you can do it with them too. So sine of x equals minus 2/5. And here we go. What you're going to do this time is you're going to need to sketch the graph. There's no getting away with not sketching it. In both cases, you have to draw something. You have to draw the cast diagram, or you have to draw a wee sketch of the sine graph. Okay, draw your sine. Like that. Beautiful. And it's minus 2/5 this time. Minus 2/5 is, let's just pretend it's there. It doesn't have to be very accurate. It's just a sketch. And you draw a line across like this. Okay. Now, here is where we're going to see my method being sick, my lovelies. So here you go. 0, 90, 180. My method's better than the graphs for this one. 270, 360. Okay. Now, in this method, in the graphing method, what you're going to do is you're just going to simply find sine minus 1 of minus 2/5, okay? So we're going to just solve it like normal, yeah? Now, if you do that, we just did this a moment ago, and it was negative 23.6. Now, that's tricky and muddly, unfortunately, my buddies. It's tricky and muddly. So here we go. This was minus 2/5. Because actually, it's to the left of the axis. So we're going to have to continue our graph along this way. We're going to have to continue sine along this way and continue this along as well. So the answer it's actually given us is this answer here, which is not in our range. So that's minus 23.6. But what we can do, though, is we can still use it, because this is going to be the same. Oh, and here's the other answers. Let's get them on too. So here's the other answers that we actually do want, are these ones and these ones, because they are in the range. So there's our answers that we're after. And here's how the symmetry works this time. Can you see that this is on a bottom bump, and the bottom bump finishes at 0? This is the bottom bump it corresponds to. So if this is the same length as that, okay? So if this distance, in terms of a distance, is 23.6, that means that this distance is also 23.6. And then also by symmetry, this distance here is also 23.6. Bit faffier than my way, I have to say. That's also 23.6. And now you can go for the final answers, just as you're used to. So because we know all those distances are equal, it's just going to be 360. The first one's going to be, let's do this one here, the 180 that's there. It's going to be 180 plus the 23.6, which is going to be 103.6. And the second one here is going to be 360 less 23.6 is 336.4. And there you have it. You can see it in both ways. Now, okay, I know I keep saying final plug, but final plug, I think cast is easier. There, I've said it. You can use graphs if you prefer, though. Okie doke. I'm going to do cast for all of the remaining ones, unless you ask me to do otherwise. If you'd like me to do it with a graph, I'm quite happy to show you it with a graph too. Cool beans. Here we go. Next one. It says, find the values of a theta in the range of 0 to 360 that satisfy that equation. Okay. A bit funkier this time, my lovelies, because it says sine of theta is equal to root 3 cos of theta. Right. So we've got two trig ratios. That's going to scupper both of our methods, whether it be cast or whether it be graphs. We can't do it because it's got two trig ratios. If only there was something we could do. If there's only a way that we had of turning two trig ratios into one. If only here, just let me stretch up here. Oh, if only there was something we could do. There it is. Oh, yeah, okay. So I wonder, is there something that we could do, my lovelies? What is it that we could do? That's right, you can hit up a trig ratio or a trig identity on it. That's brilliant. Why don't we start by dividing both sides by cos of theta? Because if you divided both sides by cos of theta, you're going to see something cool happen. You're going to have sine of theta over cos of theta equaling the square root of 3. But sine of theta over cos of theta, buddies, that's tan theta. And this is the most common kind of trig identity that they use, I would say, in these guys. But sine over cos is tan. This is the same as tan of theta equaling root 3. And now it's a normal question after we've done the identity. So back to being normal. Now I'm going to hit cast up because tan is ugly to draw as well. So there's another advantage. Tan is rubbish to draw, whereas tan is lovely, it's same as all the others, to do sex and the city with. Okay. Now check it. Same old steps as last time. We'll keep talking it through. You're welcome to pause if you want to get ahead of me, though. But if you don't want to get ahead of me, here we go. Tan of theta is root 3. Now it's a positive root 3, okay? So the answer is positive. Where is tan positive? Well, it's positive here in A, where they're all positive. And it's positive here in T, where tan is positive. So it's these two quadrants. So you draw sticks into them. Dash, 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 dash. Stick. Dash, 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 dash. Always horizontally, always to the x-axis. Now, it happens to be positive anyway, but even if it wasn't, we would do tan minus 1 of root 3. If it was negative root 3, we'd still just put in positive root 3 because we want to get an acute angle. And by putting positives in, you get an acute angle. Shift tan of root 3 is 60 degrees, so it's a nice number. Which means that's 60, and that's 60. And then we're 30 seconds away. So our final answers then are going to be this. The first time from the axis going around like this that you'll hit it is here. We're going to get the theta equals, and it's going to be 60 degrees because that's the first hit is literally that number. And the second hit is 60 more than 180. So 240 degrees. Bish, bash, bosh, solved. So I hope that's okay. You could have done it with the graph. If you like drawing that over and over and over again, you could have drawn it with the graph. But I like my way. So there you go. Happy days. And the final one, I have to show you this just for the sake of completeness, even though it kills me. Cast is amazing. It's brilliant. It'll blow your mind. Yeah, it's rubbish for if it equals 0 or 1 or minus 1. At the extremes, cast is confusing because what will happen is if you drew cast out for one that was on the extreme, so equaling 0 or 1, 0 because that's where it hits the x-axis on the graph, 1 because that's the maximum that sine and cos can take, and minus 1 because that's the minimum that sine and cos can take. If you take any of those values, the cast is going to get confusing because the angle is going to come out at 90. And then if the angle comes out at 90, then what are you supposed to do for your graph? Oh, it's ever so confusing. So, yeah, unfortunately, whenever you get the extremes like this, 0, 1, or minus 1, you should just draw the graphs, okay? So, I'm just going to jot that. Should just draw graphs for 0, 1, and minus 1. Now, if you want to see why, go ahead and just do cast on this. You'll still get the right answer with cast. It will just be very muddly because, yeah, you'll end up taking 90 from 90, and you're going to end up, oh, it's funny. So this is the one downside of cast is the extremes. So, yeah, anyway, let's do it. So cos of x equals 0 for minus 180 to 360. Well, my buddies, in this instance, I would probably, because it's given us a long range as well, minus 180 to 360, we're going to have to draw the graph in that entire range, unfortunately. And it is going to be the graph itself. And this is why the graphs aren't useless, not by any means. They're just usually cast is faster, that's all. So here we go. Let's do it. Cos is the one that starts up high. So let's do it. Starting at 1, it goes like that. And then let's go down here to minus 90, minus 180. Okay, label on our spots. It's going to be minus 90. That's going to be minus 180. That's going to be 0, 90, 180, 270, and 360. Okay. Now, we want it to equal 0. Where does it equal 0, buddies? Well, it equals 0 there. That's once. It equals 0 there as well. There's a second one. It equals 0 there as well. That's our third one. So, what's theta equal to? Well, minus 90, 90, and 270. And that's the answer, okay? So, in that instance, you're going to be better off, certainly with the graphs. Do you want me to break cast for you, or do you want me to just let you go? Yeah, I'm gonna break it for you. Okay, you ready? Okay, really quick. You can almost skip to the questions right now if you don't care why this works or why the cast is a pain. Okay, you ready? Watch cast not work very well. Sex and the city. Okay, with cast in this one, here we go. You're gonna go cos minus 1 of 0. Now, if you do cos minus 1 of 0, shift cos of 0 equals 90. You're gonna get 90 degrees. Okay. Now, 0, first of all, it's, oh yeah, look, it's even broken before I've even done that. Is 0 positive or negative? Well, it's both, so we're kind of in all of these quadrants, which means essentially, dunno. Okay, buddies, so I'd say again, just at the end of the day, anything that's an extreme, which is only 0, 1, and minus 1, use the graphs for. Okie doke, buddies? Okie doke. Right then, that's it then. All I want you to do is 2 questions, question 4 and 5. But I want you to complete every part. So I hope that you're okay at it. If you definitely don't have time, you've got 40 minutes now probably, so you should have a good stab at them, plus 20 minutes for homework. You probably do have enough time to do them all. But say you don't quite have enough time, then you can do a little bit of a mix within them, but you should really be aiming to do as many of these as you can, okay? I want you to be bored by the time you're done. Like, if you're bored, I'm going to be happy, because that's good. That means you've had enough practice, because next lesson, I'm going to make this proper tough, and so I need to make sure that all of the basics are locked right in. So I want you to do this until you're going to pull your hair out thinking, I'm so bored of this. That's like 10 questions of them. So that's what I want you to do. Take a photo, upload it, and show my homework. And that's it from me, buddies. So cast or graphs, I don't mind, whichever you prefer. I'd like you to try a couple with cast at least, just to see, give my way a chance, because you might already be good at this you might already be good at the graphs from GCSE, but at the same time, the next topic that I'm going to do next lesson, cast is so much easier for. So I'd like you to give my way a shot. So a couple with cast at least, but then you're welcome to switch over to whatever method you prefer. Cool. And so that's it for me. So I shall see you next time. Bye, buddies.